In this video, I'm going to go over the double angle, half angle, and product sum formulas. Let's start with the first example. Let us solve the equation 2 cosine x plus sine of 2x equals 0. To do that, notice that sine 2x, we need to apply the half angle formula. Sine of 2u equals 2 sine u cosine u, to break it down before we can solve. So let's solve. 2 cosine x plus sine 2x, we're going to write it as 2 sine x cosine x equals 0. Notice that the two terms on the left-hand side, they have a 2 cosine x in common, so we'll factor that out. 2 cosine x. We're left with 1 plus sine x equals 0. Well, 2 is obviously not equal to 0, so it must be that cosine x equals 0, or 1 plus sine x equals 0. So if cosine x equals 0, x must be pi over 2 plus 2k pi, where k is an integer, or x is equal to 3 pi over 2 plus 2k pi. K is an integer. Now you may be wondering, why did I add the 2k pi? Well, remember that the cosine function, cosine x, is periodic with period 2 pi. So every time I add an integral multiple of 2 pi, I wind up at the same point. So this means if pi over 2 is a solution, then pi over 2 plus 2 pi is a solution. Pi over 2 plus 4 pi is a solution, and so on. That's why I added the integral multiples of 2 pi to my solutions. Next, we have 1 plus sine x equals 0. So this means that sine x equals negative 1. Now, where is the sine function equal negative 1? That's precisely at 3 pi over 2. And recall that the sine x function is periodic with period 2 pi. So the solutions to the equation sine x equals negative 1 is x equals 3 pi over 2 plus 2k pi. Again, k is an integer. So the solutions to our given equation 2 cosine x plus sine 2x equals 0 are x equals pi over 2 plus 2k pi, or x equals 3 pi over 2 plus 2k pi, k an integer. Notice this solution here already appeared, so we don't need to mention it again. Next, given that sine theta is 3 over 5 and theta is an acute angle, find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So, first of all, notice that since theta is an acute angle, this means that cosine theta is positive and tangent theta is positive as well. We know that sine theta is 3 over 5, which in a right triangle is the opposite over the hypotenuse. So we draw our right triangle. This is angle theta. The opposite is 3. The hypotenuse is 5. And using the Pythagorean theorem, we see that the adjacent is 4. So with that said, cosine of theta is the adjacent over the hypotenuse, which is 4 over 5. Notice it's positive. And tangent theta is the opposite over the adjacent, which is 3 over 4. But that's not what we want. We want sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So why did I compute cosine theta and tangent theta? Because we're going to need them in the formulas. As you can see on the top right of the screen, we have the double angle formulas for sine, cosine, and tangent. Let's start with sine. Sine of 2 theta is 2 sine theta cosine theta. We know everything. That's 2 times 3 over 5 times 4 over 5, which is equal to 24 over 25. This is sine of 2 theta. Now, there are different ways. As you can see, we have 3 identities for cosine of 2u. We can use either one of them. So let's say we use cosine of 2 theta. That's cosine squared theta minus sine squared theta. Well, cosine squared theta is 4 over 5 squared. That's 16 over 25 minus sine squared theta is 3 over 5 squared, which is 9 over 25. And that leaves us with 7 over 25. That is cosine of 2 theta. Finally, let's look at tangent 2 theta. This is 2 tangent theta over 1 minus tangent squared theta. And that's equal to 2 times 3 over 4. That's 2 times tangent theta over 1 minus tangent squared. Tangent squared is 9 over 16. Well, that's equal to 3 over 2 times 16 over 7, which simplifies to 24 over 7. In the next example, we have to write cosine of 3x in terms of cosine x. So we start out by writing cosine of 3x as cosine x plus 2x. And we use the addition formula for cosine, which, if you recall, is cosine x, cosine of 2x, minus sine x, sine of 2x. Now, cosine x, cosine of 2x. Remember, the goal is to write everything in terms of cosine x. So if you see cosine of 2u, we can write it as 2 cosine squared u minus 1. So we can express cosine of 2x as 2 cosine squared x minus 1 minus sine x, and we can express sine of 2x as 2 sine x cosine x, looking at the first formula, the double angle formula for sine. So that would be 2 sine x cosine x. So we have cosine x, 2 cosine squared x minus 1, minus 2 cosine x, and we have sine squared x. Sine x and sine x is sine squared x. Continue. Cosine x, 2 cosine squared x minus 1, minus 2 cosine x. Remember from the Pythagorean identity, sine squared x is 1 minus cosine squared x. Now look at the two terms and notice they have a cosine x in common, so I'm going to factor that out. We're left with 2 cosine squared x minus 1. Now minus 2 times 1 is minus 2, and minus 2 times minus cosine squared x is plus 2 cosine squared x. Equals cosine x, 2 cosine squared x plus 2 cosine squared x is 4 cosine squared x, and minus 1 minus 2 is minus 3. Let's find the final answer by distributing. Cosine x times 4 cosine squared x is 4 cosine cubed x, and cosine x times minus 3 is minus 3 cosine x. Therefore, cosine of 3x is 4 cosine cubed x minus 3 cosine x. Notice our answer is entirely in terms of cosine x. Next, let's use the half angle formulas to find the exact value of sine 105 degrees. So, in this case, we have u over 2 is 105 degrees, and u would be 2 times 105 degrees, which is 210 degrees. Also notice that sine of 105 degrees is a positive number because 105 degrees is in the second quadrant. So when I look at the half angle formula for sine, I'm going to take the positive square root. So applying the half angle formula for sine, we see that sine 105 degrees is the square root 1 minus cosine 210 degrees divided by 2. Now note that cosine of 210 degrees is equal to cosine of 180 degrees plus 30 degrees. And you can use the sum formula for cosine to see that that's equal to minus square root of 3 over 2. Another way to see this is as follows. 210 degrees is right here. And if you look at this point here, which corresponds to the angle 210 degrees, it's on the opposite end of the diameter from the angle 30. You know cosine 30 is root 3 over 2, So the point on the opposite end of the diameter will have a cosine of minus root 3 over 2. So going back to our expression, we have square root 1 minus root 3 over 2, all divided by 2, which is square root. We have 2 over 2 plus root 3 over 2. I took a common denominator, all divided by 2, which is 2 plus root 3 divided by 4, which simplifies to 2 plus square root of 3 all divided by 2. 4 gets out of the radical as 2. Another application of the half-angle formulas is solving the equation cosine squared x equals sine squared x over 2 in the half-open interval from 0 to 2 pi. To do that, we start by writing cosine squared x equals plus or minus square root 1 minus cosine x over 2 all squared. The expression within the parentheses is sine x over 2, and since we're dealing with sine squared x over 2 on the right-hand side, we square everything. This equals to cosine squared x equals 1 minus cosine x over 2, which in turn equals 2 cosine squared x equals 1 minus cosine x, and that in turn equals 2 cosine squared x plus cosine x minus 1 equals 0. Now this is a quadratic equation in cosine x. We can factor it as 2 cosine x plus 2 over 2 times cosine x minus 1 over 2 equals 0, which simplifies to 2 cosine x plus 1 times cosine x minus 1/2 equals 0. This means that cosine x plus 1 equals 0, or cosine x minus 1/2 equals 0. Well, this means that cosine x equals negative 1, and where is cosine x equals negative 1? In the half-open interval from 0 to 2 pi? Well, there's only one value, namely x equals pi. That's the only angle where the cosine equals negative 1. Or, the other equation is cosine x equals 1/2. Where is the cosine x equals 1/2? There are two values where the cosine is 1/2, namely at pi over 3 or 5 pi over 3. So the solutions to the given equation are 3 in the half-open interval from 0 to 2 pi, x equals pi, x equals pi over 3, or x equals 5 pi over 3. Next example deals with the product to sum formulas. In the example, we have to write sine of 5x times cosine of 3x as a sum or difference. Since we have a sine times a cosine, we're going to look at the top right corner of the screen, and we'll see that the appropriate equation to use in this case is the third equation. In this case, 5x is playing the role of u and 3x is playing the role of v. So, sine 5x times cosine of 3x is equal to 1/2 sine of u plus v, in this case 5x plus 3x, plus sine of u minus v, which is 5x minus 3x. That's equal to 1/2 sine 8x plus sine 2x. We distribute to get 1/2 sine 8x plus 1/2 sine of 2x. Notice how we started with a product of sine and cosine, and we ended up with a sum. Finally, let's look at an application of the sum to product formulas by finding the exact value of cosine 195 degrees plus cosine of 105 degrees. We're starting with a sum. We would like to turn that into a product. And if we look at the top right corner, what is the appropriate formula to use here? The appropriate formula is the third formula, because we have a sum of two cosines. So, cosine of 195 degrees plus cosine of 105 degrees is equal to 2 cosine 195 plus 105 over 2 times cosine of 195 minus 105 over 2. That's equal to 2 cosine 300 degrees over 2 cosine of 90 degrees over 2, which in turn equals 2 cosine of 150 degrees cosine of 45 degrees. What is cosine of 150? On the unit circle, cosine of 30 degrees is root 3 over 2. 150 degrees is here. That's 150 degrees. So the cosine of 150 is negative the cosine of 30. So here's 30. So we have 2 cosine of 150 is minus root 3 over 2 times cosine of 45 degrees, which is root 2 over 2. Hence, our final answer is minus root 6 over 2.